Okay, this video is for Calc 3, specifically test number 2, question number 4. So we are asked to find the parametric equations for the tangent line to the curve with this curve x equals 2e to the t, y equals 2e to the 4t, and z equals te to the t to the fourth. That passes through the point 2, 0. So remember what they're asking for is we have some sort of curve happening, and there's this point 2, 0, 0, somewhere on that curve, and we're looking for the tangent line of that space curve just at that point. So this is what we're looking for. So how do we do that? Well, the first thing we do is we have to figure out when does our x, y, and z pass through the point 2, 0, 0. And don't forget, this is an x, this is a y, and this is a z. So what that means then is for the x part, 2e to the t equals 2, te to the 4t equals 0, and te to the t to the fourth equals 0. X, y, and z. And for the first one, the only time that can happen is when t is equal to 0. For the second one, it's when t is equal to 0, or when this part is equal to 0. But e to the 4t can never be equal to 0, so it has to be this part that is equal to 0. Same idea with the last one. T is equal to 0 is fine, but this et to the fourth could also be equal to 0, but that is undefined. This can never actually be equal to 0. So we have then the case, clearly we're talking about when t is equal to 0. Then the next thing we have to do is find the rate of change for our r prime vector. So our r vector, if we put the x, y, z in a vector, would look like this. So r would be 2e to the t, te to the 4t, and te to the t to the fourth. That would be our r vector. So then we need to find the r prime. So for the x parts, x prime I'm going to call it, is just the derivative of 2e to the t, and that's equal to 2e to the t. And then the y part is the derivative of te to the 4t. Take its derivative. So here we have to use the product rule. So when I take the correct derivative, I get e to the 4t plus t times e to the 4t times 4. And then for z prime, it's te to the t raised to the fourth. Take its derivative. So once again, this is the product rule. So it's e t to the fourth plus te to the t to the fourth times, then the derivative of the exponent is 4t to the third. So those are my derivatives. So now I plug in t equals 0 into my r prime. So like that. And so when I do that, I would get x prime evaluated at 0, so that would be equal to 2. And I'd get y prime evaluated at 0, and that would be equal to 1. So that would be 1. This part would be 0. And in the last one, z prime of 0, I would get also 1. Because this would be 1, this whole part would be 0. Okay, so then that means that I have r prime evaluated at 0 is equal to the vector 2, 1, 1. That's the vector. So then for what we have to do is put this together. So through the point 2, 0, 0 would mean we need this line. I'll just call it RT for r tangent, would be equal to 2, 1, 1 as a vector times t plus this other vector 2, 0, 0, r tangent. But they want the parametric equations, so let's write out the parametric equations. So the parametric equations for the tangent vector, the x part would be equal to 2t plus 2, and the y part would be equal to just t, and the z part would be equal to just t. And in case you can't remember where I got that, I take 2 times t, that's the 2t, and plus is this plus, and then the x component is 2, and the 1 times t is t, plus 0 for the y, and the 1 times t is t, plus 0 for the z. Now, one thing that does happen in WebAssign, so in WebAssign, can be a pain because they actually want you to write your answer like this: 2t plus 2, comma t, comma t, and don't put any vector symbols or anything like that. It just goes in that way. Okay, I hope this helps.